good morning, everyone. My name is Sida, and welcome everyone to this MyReskill IoT training. So today will be our first hands-on session. So we shall begin now. Okay. So when it comes to IoT, it's all about embedding software, electronics, network, and sensors that allows these objects to collect and also exchange data between them. So this is what we are going to guide you throughout the training. Okay. So industrial factory with smart IoT management. Smart IoT management allows factory managers to automatically collect and analyze data to make better informed decisions and also optimize the production that is been running in the production floor. So IoT technology. IoT technology is leveraging both wires and also wireless connection that enables the flow of data and provides the ability to monitor and also manage process remotely and change production plans quickly in real time when it's needed. So we can take fast action when we notice that something that is incorrect in the monitor. Okay, let me go through a small example. As you can see here, there is temperature sensors, light sensor, and so humidity sensor. These sensors can be placed anywhere in the production floor. This isn't not necessary to be in one building. It can be any floor, any surroundings. And then these sensors then will be connected to Arduino. Okay, this blue board here is actually Arduino. And then this will take the received data. Data here means the readings from these sensors, from all the sensors. And then send it to the Raspberry Pi. So this green board here is actually a Raspberry Pi. And then finally, the Node-RED. Node-RED is actually a software for dashboarding purposes. So this Node-RED will be installed in Raspberry Pi, and then this will be used to visualize this data around the buildings for monitoring purpose and more. Okay, so example here, we can take temperature sensor, light sensor, and humidity sensor. This is the main three we listed out here. There's actually more we can use in production floors. So temperature sensor, why do we need temperature sensor in the building? For example, when we are using some kind of chemicals or production, the motor, the servo, the machine, if it's running too long and the temperature increases during the surrounding, it might damage some products. So we can use these sensors to monitor the temperature in the surroundings and will alert us so we can take quicker actions. So without IoT management, the technicians have to inform the manager have to inform the boss, and then there comes the big cycle where we will waste more time on it. So this IoT management is a direct to any level of management. So it will alert them, and then they will take quicker process to stop this action. So example for light sensor, if the light is too dim or too bright, we will know maybe there's something wrong with the light or bulb, so we can take more quicker action on that. And for example, the humidity sensor, if humidity is to measure the humid during the surrounding, you can measure it's like the environment there is too cold or too hot, warm, it might damage some products running there. So this can alert us to change the temperature around the building. So as you can see, there's more sensors we can implement: oxygen level, carbon dioxide. These sensors can be used during chemical productions. So some of those will be wearing masks, we will not notice. Some of them will be not wearing masks. So this will alert them, and then they will take quick action. It will be a mass swift action for them. Okay. So all of this data, we can say information that we retrieve, are the readings from the sensors. Those sensors will be retrieved by Arduino. So Arduino is this blue board here, it's a microcontroller. So this board will receive the sensors readings, and then you will send it to this Raspberry Pi here, this green board here. So then this Raspberry Pi, inside of this is actually a Raspberry Pi. I can say it is a smaller version of a normal PC. we can say a mini computer. So this final one, Node-RED. Node-RED here is a dashboarding web-based software. So this software will be installed in this Raspberry Pi. It's like installing a software in your PC, same condition. So then once we retrieve the sensors data, we can do multiple dashboarding purposes. And this can be viewed in any PC throughout the buildings. Okay, so our first agenda for today is we'll start off with a little introduction on Raspberry Pi, the one I showed you just now. And then Arduino board, which is the blue board I showed you just now. And then also we'll be focusing on two sensors for this throughout this training. So we'll focus on those two sensors only. So before we okay, so before we putting our hands into the hookup will be a better understanding for what boards are we handling. I need to show them why am I presenting in. Okay. Okay. So before that, to enable me to show you, I need to show you my screen, my slide, and also I will show you a little picture on this board. So in order to do that, we will do a little bit of setting on the Zoom. So I need everyone's help for this. So is everyone okay? So as you can see, there's a small view button on the right corner. What's there? Yeah. Okay. So can everyone please help me on setting the side-by-side speaker option so that everyone will be able to see two screens at once. Okay, so you can follow these slides for better example, or I can guide you throughout the setting. Okay, you click on the view option and then you select side-by-side speaker. Okay, it will be a drop down there and you select side-by-side speaker. Okay, once you have clicked on the side-by-side speaker view, there'll be two screens. One screen will be bigger and the other screen will be smaller. So I would like everyone to drag there's a bar there, drag and put it in the center. So you will have two equal screens. All right. So everyone will have two split screens like this, equal screen. So I repeat again, there'll be an option between these two screens, which you can drag and resize the screens. So now you have to drag and make both screens equally the same size to view both my slides and also my video.
Now LIS logo ni right?
Yes, yes. Okay, can we continue? So everyone should have two screens now. One presenting my slide, another one will be my video. So please let me know if you can do it. Okay, if you're not able to do that, please let me know in the chat. I will tell you again. Okay, so what you're going to do is there's an option on the right corner, top right corner there. There's a view button. So you want to click on it, and then there will be a drop down. Select side by side speaker. You can see my slide if you're not sure. Okay. Everyone, please click the view option on the top right corner. There's a button on the top right corner that says view. Please click on that. After clicking on it, there will be a drop down of few selections. Please select side by side speaker. Once you have clicked on that, there will be two screens appearing. And there will be a drag option. Please drag and resize the screens. So your screen should look like this. One will be my slide, another one will be my video presenting. Can everyone get that done? Okay, we shall continue again. So we'll take a look on the Raspberry Pi. This is the Raspberry Pi. Okay, I'll go through a little introduction on this Raspberry Pi. This is actually a single board computer, which means it acts exactly as a normal computer. So there will be slightly difference between this Raspberry Pi and a normal computer that we are using. It's also a low cost compared to a normal computer. That is why most of us we prefer using Raspberry Pi instead of a computer. Smaller in size and slower in cost. So this Raspberry Pi supports a standard keyboard and mouse. So you see here there's USB, so we can plug in our keyboard and also our mouse. It also has a built-in Bluetooth 5.0 and also a dual band Wi-Fi connection. Means it supports Bluetooth connection and also internet connection. Okay. So the Raspberry Pi also supports USB, which I meant USB, which you can plug in your pen drive or hard drive for the Raspberry to read, and also HDMI ports. Supports HDMI connection to your screens, also your monitor. And then finally, it has Ethernet connection. So if you don't have a wireless connection in your home, you can use this Ethernet. So basically this Raspberry Pi, this board here, is actually a mini computer which you can use compared to a normal big size PC. Okay, so let's take a look on the revolution of Raspberry Pi over the years. It all started in the year 2012, the first Raspberry Pi production, and then the Raspberry Pi 2, then Raspberry Pi 3, and then finally with the Raspberry Pi 4. So the Raspberry Pi 4 is the latest version of Raspberry Pi. So the Raspberry Pi that everyone has now in their starter kit is also the Raspberry Pi 4, which is the latest version of Raspberry Pi. There are actually many more models in Raspberry Pi depending on its RAM. As you can see, there's a model A, model B, and so on. So you can see Raspberry Pi 1, model B, and then Raspberry Pi 1, model B, A. So it goes on with different models specifying different RAMs, different memory space. So throughout the year, from 2012 to 2019, which is the latest Raspberry Pi. Okay. Now let's take a look on some important components of Raspberry Pi and its function as well. The first one, we have the GPIO ports. These pins allow you to connect to any electronic components, such as, for example, we can take LEDs and buttons and even some sensors to connect to the Raspberry Pi. So the connection is you simply connect the electronic components to the GPIO pins on the Raspberry Pi. So these are the pins here, a row of pins. Okay. So we can connect these these components such as LEDs, buttons, this whatever sensors we have to these electronic pins here using jumper cable. So that is the connection between the sensors and also the pins to the Raspberry Pi. These GPIO pins can be configured as either general purpose input or general purpose output. So we can give it the input and we can give it make it as an output as well. So this Raspberry Pi has 40 male GPIO pins. So this is 40 pins here. That supports only digital input and output. It doesn't have analog output. So these pins is for you to connect to your external components. Right. So then we have the USB ports. Okay. So we can see here on the Raspberry Pi, we have 1, 2, 3, 4 USB slots here. So what are these slots for? This is used to connect to our mouse and also keyboard. There's a total of 4 USB ports here. The number and the type of USB ports on the Raspberry Pi depends on the model. So if we are going to use the older version of a Raspberry Pi, it might be only 2 USB ports here. So the USB port enables attachments of peripherals such as keyboard, mouse, webcam, and also USB drives such as your pen drive or hard drive. Then there are 2 types of USB on the Raspberry Pi. Okay, you can see here there's a color difference in these 2, which is black, and these other 2, which is blue. There's a difference in it. So the difference between these 2 types of USB ports is one is actually USB type 2.0, another one is 3.0. So what's the difference? It's actually the data transferring speed. So the USB type 3.0 has a faster transferring speed compared to the USB 2.0. So why would I specify 2 different ports here? Is because if you are using a component that is an older version, it supports lower speed. So if you're using the newer version, it supports faster speed, transferring speed. For example, your mouse and your keyboard and also your pen drive as well. Okay. So now we have the SD card slot. So this board here comes with an SD card slot. SD card slot you've seen on many devices, such as your phone or camera. So the SD card is actually located beneath the Raspberry Pi. So this is the top view. This is the bottom view. You can see there's a metal plate here. This is where your memory card slot is. Okay, this is where we slot the SD card. In the SD card is where the operating system software and your files are stored. So every computer needs its OS. So in the Raspberry Pi, the OS is stored in the SD card. So this SD card is pre-installed with Raspbian OS. As I mentioned, all computers need OS, and we have also pre-installed the OS for you in this Raspberry Pi. So you don't have to worry about it. Okay. One advantage of using this SD card is that you can have several SD cards, each with different operating system. There's actually many operating systems for Raspberry Pi, for your information. So if you're using a different SD card, it might have a different memory running operating system. So how do we change the SD card? Is we can simply power off, switch the SD card, and then reconnect to power, and you can have a different operating system running in the Raspberry Pi. So another good advantage is, in case if your Raspberry Pi burns out, we just simply remove the SD card, plug it into another Raspberry Pi. Your information, your OS will be still running the same. So that's the benefits of an external SD card. Because some PCs have built-in OS. The SD card is in the starter kit. We will not look at the starter kit for today. We will look it for we will go on hands-on tomorrow, so you don't have to worry about it. So if you really want to take a look, this will be in your starter kit. So this is the adapter, and this will be SD card. Don't worry, we will show you how to hook up this tomorrow. We're just going to take a look on Raspberry Pi and its components for today, so we get a little knowledge on what we are doing tomorrow. Okay, so now we'll take a look on the Ethernet port. So this is used to connect the Raspberry Pi to a network with so it's wired, so we're going to use a cable for it, RJ45 cable. So many of us use a LAN cable to connect to your PC. It works as the same way. We connect it to the Raspberry Pi to this Ethernet port here. Okay, another thing is Raspberry Pi can also connect to a network using wireless, like a normal exactly like a normal PC. You open your Wi-Fi, connect to your Wi-Fi connection, and then it's all up with a wireless connection. Depends. You prefer the Ethernet port here or your wireless. Wireless we will configure tomorrow in the Raspberry Pi. Okay, so we have the audio jack. Take a look on the audio jack. Okay, the Raspberry comes with an audio jack, which you can connect your headphones or speakers here. So if some of you are listening to music, you can just directly connect to your headphones or your speakers here. It's similar to sockets found on other multimedia devices such as iPods, MP3 players, and smartphones. So the similarity for Raspberry Pi and a PC is very close. It has almost all the components to a PC. So using this will be not a new trend. Okay. So this is the jack. Your earphone speakers will be connected to this. Okay. The micro HDMI port. Okay. If you take a look, you can see one here and another one here. Okay. This is the micro HDMI. The one connected to your PC will be a normal size of HDMI cable. So for the Raspberry Pi, it comes in the mini version, which is a micro HDMI port. So this is where you connect to your monitor, projector, or your TV screen that you'll be using to display the output from the Raspberry Pi. So if for a normal PC, and then you have a desktop. So the desktop is where you view what is happening in the PC. You have your interface. So it's similar to this Raspberry Pi. The interface will be displayed on the monitor. The Raspberry Pi comes with the micro HDMI, which means the HDMI port is smaller. So you can see here, it's smaller compared to the one we use to connect to our monitors. Previous version of Raspberry Pi comes with bigger size. So if you are going to take a look on Raspberry Pi 1, 2, and 3, will be the size will be bigger, the same size as the one we plug into our normal computer. So the latest one is a newer version. So it comes with two HDMI ports. So we are able to connect to two different monitors. So the first one we will have is the HDMI 0, and second one we have the HDMI 1. Okay, and then for the finally we have the micro USB Type C power connector. Okay, take a look. This is the USB Type C. So now the latest smartphone is using USB Type C. So this is the same one as well. So this is where you connect to the power supply. So we have a power adapter. You connect it to this USB port here. The power supply requirements differ by Raspberry Pi models. So this is the latest one. So you're using the latest USB type. So if you're going to use the older version, it might be USB Type B, micro Type B. So all models up to the Raspberry Pi require a micro USB connector, while the Raspberry Pi 4 uses USB Type C connector. So this is what I meant by C. This is a USB Type C. Previous version uses USB Type B. So a warning icon will be displayed on the screen if the USB Pi detects if the power supply is low. So we are not recommended to you connect using USB to your computer to power up this Raspberry Pi. It's recommended you use the adapter. If the Pi detects a low voltage, it will show a warning icon on the screen, which will harm the Raspberry Pi, and your function will reduce as well. So this is all for Raspberry Pi parts and the components. If you have any questions on Raspberry Pi, do let me know before we move to the Arduino board. So please feel free to ask if anyone have any question, or you can type in your question in the chat box. My team will answer you. So you have any questions on this? Are you clear with all the components and parts? Yes, a small reminder, we will be not working on the starter kit for today. So we will take a look on it on tomorrow. We'll unbox it tomorrow together. So I'm just going to show you the board only for today. We're going to explain on both boards today. So we will just focus on both boards. Unboxing will be done tomorrow, so you don't have to worry about it. Thanks. So I think no one have any questions on this Raspberry Pi board. So we'll move on with the Arduino board. Okay. So this is the Arduino board. You have this in your starter kit, but don't worry, you'll take a look on it. We will unbox it tomorrow. If you take a look on the Arduino board. Okay. So this Arduino is actually a microcontroller, which means it is a programmable board. Programmable here means it's a set of instructions that we write in order to function as we are instructed. As this board are instructed, it works as we are programmed it. Okay, there is only one USB port connection to this Arduino. Okay, you take a look. This is the USB connection. So there's only one USB connection. Unlike the Raspberry Pi, it has 4 USB ports. There is also USB Type B. So this Arduino only comes with one USB port. Okay. The Arduino also takes low consumption power to power on. So it needs 5 volts to power up. So unlike the Raspberry Pi, it needs an adapter. This just needs a USB connection to the Arduino and will power up just fine. So Arduino was basically designed for learning purposes and also prototyping use, which means it is used for testing purpose before implementing it into the real deployment. So many of us use Arduino as a starter platform for prototyping before implementing it to the real project, to real environment. So we use this to study the effects. Okay, so there are many types of Arduino boards, but here I'm going to focus 6 well-known boards of Arduinos. So first, we have the Arduino Uno. Okay, so what you are looking here is an Arduino Uno. This is the commonly used Arduino board. And this is the board that everyone has in your starter kit. So this is the basic programmable board. This is the basic one, the first ever Arduino Uno is in the family of Arduino. So next we have the Arduino Bluetooth. The Arduino Bluetooth comes with a built-in Bluetooth module, which means this board supports Bluetooth connection. So if you want to connect this board using Bluetooth, you'll be working just fine for command purposes. Then we have the Arduino Mega. Okay, as you can see this Arduino Mega here, this board has more input and output pins to be connected compared to the basic Arduino Uno. You can see the pins. This Mega we have more pins. Hence, making this board will be slightly much bigger than the Arduino Uno. Compare in size, this Arduino Mega is slightly bigger than Arduino Uno. Okay. Next, we have the Arduino Nano. This board is smaller in size compared to the other Arduino boards, which we have just take a look with, and it lacks only with a power supply jack. So this Arduino Nano does not comes with a power supply. You can see this Arduino Uno here, it comes with a power. So this Arduino Nano does not come with a power and is much smaller in size. Next is we have the Arduino Leonardo. Okay, this board comes with a micro USB Type B cable connection. Okay, so what's the only difference here I can say is the USB type. So this is a USB Type B, which is the Leonardo uses micro USB. So the USB connection on these both boards are different. Okay. Lastly, we have the Arduino Ethernet. This board has a RJ45 connection port. Similar to the Raspberry, we just take a look. This is used to connect the Arduino to a network with a cable, again wired, making this board able to connect to the internet. So if you ask if this board is able to connect to the wireless internet, then we have to get the board that supports wired wireless internet connection. There are actually many boards around, so I just focus on these 6 commonly used Arduino boards here. So let me go again. First, we have the basic board, which is the Arduino Uno, and then we have the Bluetooth, which is a built-in module, and then Arduino Mega, more I/O pins, Arduino Nano, smaller in size, Arduino Leonardo. The USB uses micro USB B. See, in case you can see, it's almost similar with the Uno here. The only difference is the USB. And then finally, we have the Ethernet. This is used to support Wi-Fi connection. It's a RJ45 connection to your Ethernet cable here. Okay, now let's take a look on some important components of Arduino and its function. All right, so if we take a look just now, the USB port. So we can look again, USB. So Arduino uses only one USB port, which is the USB type B. So this type of cable connection is called the USB type B. The USB port on the Arduino board can act as a power source of 5 volt to the board to power up. So as I mentioned just now, it only uses very low consumption of power. So only 5 volts is enough to power up this board. So the 5 volt can be supplied from this cable. Okay. The Arduino operating voltage is only 5 volt, which is enough to power up the board, which doesn't need an external power supply like the Raspberry Pi. So that's the difference. It uses a low consumption of power to power up this board here. So this, as you can see, this port here is also act as a voltage source for the board. So you should just power up this cable here, and you connect the other part of the USB to the PC. It's enough to power up this board here. Very low consumption. So it uses low consumption. Okay. Next, we have the types of USB. So I'll show you the USB which has been will be used to connect to the Arduino. Okay. This is actually a single wire which have 2 different USB type ends here. So this is the USB type A. I think everyone has seen this before, the commonly used USB. This is called the USB A. And this is the USB type B. So different boards have different USB connections. So this A here, USB type A here, will be connected to a PC. In our case here, it will be the Raspberry Pi. So this connection here will be going to the Raspberry. This will be connected to the Arduino. So this cable can act as a power supply to the Arduino. And another thing on this cable here is used to transfer data to the Arduino to the Arduino and from the Arduino. Means data can be exited from Arduino and it can be going into the board using this cable. This will be data transfer. So we take a look. So this is where we connect. Don't worry, you will connect this tomorrow. Okay, let's look at the power supply. So I have shown you this now. This is the power supply. This is where we plug in. So this is the Arduino also has a power supply connector which can be powered up externally using a power supply adapter. So we can also power up this using the adapter. similar to the Raspberry Pi. All right, so we then have the VIN pin. Okay, so you take a closer look, it will be labeled as VIN. It's okay, we'll show you. So this pin here, okay, take a close look. This VIN pin here on the Arduino board is also capable of powering up the board. If you ask how is, simply you connect your battery. Battery will have two wires, one to the ground and one to the power. So the power will be connected to this pin in order to power up this board. So there are actually many ways to power up. There are a total of 3 ways to power up this Arduino board. Okay, we're going to go through again. The first one is we're going to use the cable. We can plug it in here. The second is we use the power adapter, which is this, to connect it to. And the last one, which is the way to connect to power up, is to connect to the VIN pin here. So all this connection here is depending on the way we are going to use the Arduino. If you're going to power up using the adapter, it's because we're going to need to power up the sensors as well, the components connected to the board. So that will take more power. So we use this. We're going to use less consumption of sensors, then we just plug in this USB. It's enough to power up. All right. So let's take a look on the LEDs on the board. There's many LEDs here. Some of them indicate some purposes. So LED indicator, Arduino has this built-in LEDs on the board that helps us to indicate certain information. So example, for some LEDs, you will indicate some information, so we're able to notice it. There are 3 LED indicators on this Arduino board. The first LED is to indicate if the board is powered up, which is the power LED indicator. Okay, so we can see a on LED here, a one that's written on. Okay, it's okay. You can take a look. So some of those who have unboxed it from the box, you can take a look on it. It will be written 0ON, which is on. So this LED here, it will power up when there's power source to the Arduino board. So we can indicate that this board is powered up. So the first LED is to indicate if the board is powered up, which is the power LED indicator. So this LED will light up if there is power source to the board, indicating that the Arduino board is turned on. Means the Arduino board is alive, so you'll know by looking at the LED. If the Arduino light doesn't light up, then you know the board is faulty. Okay, next LED is the TX RX LED indicator. TX here means transmitting, which means data transmitting out from the board. And RX means receiving, which is the board receiving data. Okay, so on the board here you can see there's RX and also TX. You can locate it, RX and DX. So TX is transmitting, RX is receiving. So transmitting here means data transmitting out from the board. Means data is going out from the board. Means this board is transmitting data. Then the TX will light up. Okay, and the RX here means receiving. So if the board is receiving any kind of information, data, this RX will light up. So this is easier for us to track if the board is functioning well. So if we are sending data to the board and we see the TX, the RX is lighting up, okay, we know the board is receiving data. So this is how we indicate whether the board is functioning as we wanted. Okay. And finally, we have the test LED. LED that is labeled TEST, test. This is to test whether the board is functioning properly. If sometimes we just know, we can only see the board is light up, we doesn't know it's functioning. So this is how we test it. We simply trigger pin 13. You can see here pin 13, there's many pins here from 0 up to 13. So if you trigger this pin here, and then if the LED light up, we can know that the board is working fine. So if this 3 LED works just fine, so we know the board is working in proper condition. So if one of the LEDs are not working as you wanted, then you know the board is faulty. We have to check on it. So if I go through again, 3 LEDs on the board. The first one is the on LED. So if to indicate if the board is powered up. Next we have the TX LED, which means that Arduino transmitting data out from the board. This light will actually blink. I can say it will blink. And then we have the RX LED. If the board is receiving data, the RX LED will blink. And then finally we have the test LED, which will be triggered on pin 13, and then the LED will light up. So these are the 3 LED boards that we're supposed to know in order to check, to counter check if the board is working fine. Okay. So now you take a look on this reset button. At the corner here, we can see there's a little physical button which we can press. This is called the reset button. So what is reset? Reset in Arduino means restarting the program that is already been running in the board. The program in the board starts from the beginning and the hardware is reset in case of any error in execution of code in the Arduino program. So if we click on this button, it will trigger the program in the board to start from the scratch, to start from the beginning. And also it resets any hardware in case of any error when we are executing the program. So this is to keep track, to check if the board doesn't overload and burns up. This works in the same manner as the restart button in your computer. So some of you, you can see if our program is lagging, we restart. So it's the similar function for this. Okay, there's 2 ways to reset the program in Arduino. So there's 2 ways we can do this, enable this reset for this board. The first is the button on the Arduino board. So we can reset by simply clicking on the board. This button here, click, it resets the program. And then the other way is we trigger the reset pin here. So similar to as I mentioned, the win pin, there will be a reset pin labeled as RESET. So if you trigger this pin, it will reset the program in the board. Same, there are these 2 ways to reset. So resetting is actually restarting the program from the top. So we can either click on this button and also trigger this reset pin here. Either way. Okay, so we will take a small break. So you can take a look on the boards. If you don't understand anything, I will answer for you again. So we just take a small break. So we'll take a 10 minutes break, and then we'll continue. So in the meanwhile, you guys can take a look on Arduino and also Raspberry. If you're not sure with any components, you can get back just in the chat or also the WhatsApp group.